In this video, we present the simulation made in Robopro of an automated system for a tire center. The process has four main stations: raw material, entry, working station, transport to the conveyor belt, and finished product exit. The system uses different robotic elements, such as sensors and push buttons, the photosensors and electric motors, pneumatic pistons, and air compressor. These components help control the movement and position of the tire during the weld process.
Raw material entry. Here the material arrives to start the process. We have two inputs. The first one is a photosensor. It detects if there is an object or not. If there is light, there is no object. If there is no light, it detects the material and the signal changes from 0 to 1. The second input is a push-button sensor. The rotary table touches the sensor while it is rotating, so the signal is active only when the table is in position. For the outputs, we have motor 1 and piston 1. The motor uses compressed air and the piston pushes the material. The piston works only if both sensors are active at the same time. When this happens, the table stops, the piston pushes the material, and then the table moves again to station 2.
The working station. Here, the material is positioned and processed. We have one main input. It is a push-button sensor. When the operator presses the button, the sensor sends a signal to the controller. When this happens, two actions occur at the same time. The first output is solenoid valve 2, which activates piston 2. This piston is double acting, so it's moved forward and backward. The second output is a motor 1, which controls the rotator table. The table stops for a specific period of time. While the table is stopped, the piston moves forward to position or work on the material. Then the piston returns to its initial positions. After the programmed time finishes, the rotator table moves again and the process continues to the next station.
During the third stage of the process, the pneumatic component is transferred from the rotary table into the conveyor belt. Once the pneumatic component completes its operation on the rotary table, the signal is sent to the piston as an input to initiate the third process, passing to the controller as well. When the system receives this signal, it generates an output that activates the movement of the third piston, which pushes the pneumatic component into the conveyor belt and stops immediately. At the same time, as a second output, the conveyor belt is activated and the rotary table stops operating if no element is detected in the previous stage of the process. After all these processes have been successfully completed, the system moves on to the final stage.
The exit stage. In this station, we use a photoelectric-like sensor as the input. This sensor detects the presence of the tire at the exit area. When the tire interrupts the light beam, the sensor changes its signal from 0 to 1. This signal is sent to motor 3. Motor 3 activates the conveyor belt, which moves the tire out of the system. If there is no object detected, the sensor does not send a signal, and the motor remains off. This ensures that the conveyor belt only works when a tire is present. Once the tire leaves the sensor area and the light is detected again, the signal returns to 0, and the motor stops. This completes the final stage of the process, allowing the system to finish the cycle and get ready for a new tire.
So, at the end of the cycle, the tires leave the system and the process is ready to start again with a new piece. The cycle time depends on the coordination of the sensors, motors, and piston in the simulation, or fits the mistakes. In the real life, this time can change because the mechanical problems, work parts, human delays, or changes in the air pressure in the pneumatic set.